Hi, my name is Jamal Thorne, and today I'll be speaking to you about walkthroughs. Before we start talking about walkthroughs, I'd like to define a few key terms. Program verification, which is the process of determining the degree to which a software product fulfills its specifications. Desk checking, which is the tracing of a program on paper. Inspection, which is a verification method in which one member of a team reads the program or design line by line and the other members point out errors. Walkthrough is a verification method in which a team performs a manual simulation of a program or design with a sample test input. It's kind of like you planning out your journey to or planning out your path to a new mall. You plan it out, you map out all of the stops that you're going to take. You're going to map out where you buy your transit card, you map out where you get gas, you map out where you park, you map all of this out before you make a long journey. So a walkthrough is basically like a walkthrough of a video game. Why is it useful? Walkthroughs help you check for known trouble spots, such as loops that don't terminate, such as variables that are used before they're initialized, or incorrect order of parameters in the function call. It also saves time since testing is extremely time consuming. Here we have some sample code, and in this code we create an array that has 4 elements. The first element of the array is initialized to 5, the second is initialized to 6, the third is initialized to 7, and the last is initialized to 0. Now here we have a for loop, and what our for loop does is it adds the 3 elements of the array and stores it in the 4th. Here we have a walkthrough of that program. What I did was I wrote out the array, the first element, the second element, the third element, and the 4th element. Now here I is equal to 0. This is before the for loop is executed. Before the for loop is executed, the first element is 5, the second element is 6, the third element is 7, and the last element is 0. If we execute the for loop one time, the first, second, and third element remain unchanged, but the last element becomes 5. Because what it does here is it added 5, what's in the first element plus the last element, and it stored it in the last element, which we get 5. If we execute the for loop a second time, the first, second, and third elements remain unchanged, but the last element changes once again to 11. What happened here was it added the 5 that was previously the 4th element to the 6, which is the second element, and got 11. If we execute the for statement a third time, we see that the first, second, and third elements remain unchanged, but the last element again changes. It's now 18. What it did was it added the 11 that was previously the last element to the 7, that's the third element, and it got 18, and it stored the result in the last element. Now in the grand scheme of things, how does this matter? Walkthroughs can help you detect errors earlier in the design process, which can help to diminish the cost associated with correcting errors. Here we have a table that shows that as the later the errors are discovered in the design process, the more expensive they become. Here's in conclusion, a walkthrough is a manual simulation of a program through using test values in paper. A walkthrough is an extension of desk checking. Walkthroughs help to catch errors before they get to the testing stage and ultimately become expensive. In a walkthrough, you can write down the important variables and track their changes as each line of code is executed.